Good day, everyone, and welcome to today's physics class. In today's class, we will be looking at the concept of position, distance, and displacement. For the new scheme just provided, this one is in grade 10, SS1, okay? Now, let us look at position. What's position? Now, in physics, position is referred to as a point in which an object is located. Or you can simply say it's a point where an object can be found in a plane. Where an object can be found. Look at the position. This is a position, okay? Now, the position of an object is determined by its coordinates. You know, in Cartesian plane, we have two perpendicular axes, which is the y and the x axis. Look at it here. If we have it like this, we have two axes like this. Now, on this place, on this axis, we are trying to locate an object. If an object is placed here, so it is traced down to this y axis, this direction, and it also traced down to this. So at this point, if this is x1, this is x, this is y, then this is y1. So at this position here, where this object is located, is x1, y1. So simply just put that as a point on the plane where an object can be located or where the object is found. That is the easiest and the simplest definition to position. But now let us look at distance. When we talk about distance, distance is a scalar quantity in the sense that it has just magnitude but no direction. Now let us define distance. Distance is a gap between 2 points, or gap between two positions. Look at it here. If I have point A here, okay, and I have another point B, along this plane, all right? So from here to here is our distance, okay? It's a distance. It is a gap between 2 points. And we say that what? This is a position and this is a position. If we come to the Cartesian plane, when we come to this Cartesian plane, if we decide to have another location again, this another point, now the distance between these points, it will have to be drawn. Let's do it from here. If I have 2 points or 2 positions on a plane, let's say, for example, I have in a position here, then this is position x1, y1, okay? Then another position again, we have x2, then we have y2. This is your x-axis, and this is your y-axis. Now, distance simply means a point. This is a point from here to here, the gap between this. So we have to trace it down, thereby forming a large triangle. And this is your position here, where we have x2, then y2. And this forms a coordinate. So this is a coordinate, this is a coordinate. Now, the distance we are talking about now talks about from here. Let's say x, okay, or this xy, because we're talking about difference between here and here. That is distance. And we can determine the distance between 2 points on this plane by what taking out this triangle. If you have this like this, okay, let's say this, we have another point here, okay, we have another point, and we have another point here, and we must trace, this is the distance we're looking for, trace it down. Here we are forming what? A triangle. And from here to here, this is your x1, this is your x1, this is your x2. Which means we have increased from x1 to this point. So this becomes x2 minus x1. And we have increased on the y-axis, moving along the y-axis. We have increased here. This becomes y2 minus y1. Okay. And we are looking for this distance here. We can call here d. Okay. If we want to do this, now we can relate this to our coordinate geometry. If you bring out this triangle, we're having a triangle here. You can remember the Pythagoras theorem, where we have the d square is going to be equal to what we have here, assuming here is AB. Let's say this one is point A, this is point B. We can call here C. So you're going to give us AB squared plus, we have BC squared. And at the end of the day, we have, what is our AC? Okay, this AC here, rather. AC, okay, this AC, this AC. AC here, we have what? X2 minus X1. We have X2 minus X1, then all squared plus, what is our BC? We have y2 minus y1 is to find the square root according to Pythagoras theorem. So your D becomes the square root of, we have x2 minus x1 all squared plus y2 minus y1 all squared. So this is what we use to determine the distance between 2 points along the plane. So in our next video, we will look at some examples. Let us look at how we determine the distance between the 2 points. And it is measured in units. We call it unit, because we don't use the SI unit here because we are talking about the coordinate distance between 2 points. Okay. So my next video, we will look at that. Now let us look at displacement. What do we understand by displacement? From, let's use the cardinal point to illustrate this. If a car starts moving, this is the north, this is the south, the east, and the west. A car can decide to move from here, from the north, and coming down as it gets to this point, at the point, and decide to move down this way. Okay, the car can decide to move and get to this point. So in that case, we say that the car has moved in the direction northeast at an angle. This is the direction with which it has moved. So this is the direction where it's moving at an angle. The separation between the starting point and here. This is where he is now. And for us to get the displacement, we now talk about this particular distance it moves in a specific direction. Now, where is the starting point? This is the starting point. So this is where the displacement goes. All right, let's say, for example, a car or an object moves from point A here, it moves, then comes here again, comes to this point, get to point B, and it moves again, comes to this point C. Somebody asks you, what is the displacement of the car? Displacement is not this total distance. It's a particular distance. Look at his starting point. His displacement should be from here to here. That is the displacement. So distance in a specific direction. And the unit of displacement is meter. Both distance and displacement, they all have the same unit. The only difference between the two of them is that distance is a scalar. It has just value, which is the size, the magnitude, but no direction. And meanwhile, displacement, D, has both magnitude and direction. So in that case, it's a vector quantity. So in our next video, we look at calculations involving distance between 2 points on the plane. So I want you to stay tuned, follow, hit the like button, and comment. To do so, God bless you. Bye.